Hello everyone, and welcome to our 8.2, 8.3 notes on triangle similarity. Today we're going to be specifically focusing on triangles. The last few days we've been looking at different types of polygons, but today we're going to look at different ways and shortcuts to prove triangles similar to each other. Our warm-up question is, what is something that brings you unexplainable happiness and comfort? Mine is sitting in a pile of warm laundry, like right after it comes out of the dryer. I just love that. It just makes me feel better. If I've had a bad day, that's what I do. Okay, so similar to how we proved triangles congruent. So if we are proving triangles congruent to each other, that's where they're the exact same. There were 5 shortcuts. We called them the core 4 plus 1. So it was side, 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 angle, side, sass. We talked about how my daughter is sassy. And then J is just ASA. That's my son. He's like the reverse of that. And then we have AAS. All 4 of these, the core 4, work for all triangles to prove them congruent. And we said the plus 1 was HL. That only works for right triangles. But now we're not going to be proving triangles congruent, we're going to be proving triangles similar to each other. And there are 3 shortcuts that are going to work. The first one we're going to learn about is AA similarity, and then we have SSS similarity, and then we have SAS similarity. Notice how this symbol is included here. This shows that we're not proving them congruent, we are showing that they are similar to each other, which just means that they're the same shape but different size. And so our very first one we're going to investigate is angle-angle similarity. Angle-angle similarity. So double A. If 2 pairs of corresponding angles are congruent, then the triangles are similar. Okay? And we learned something called the third angles theorem that tells us that if 2 out of the 3 angles of one triangle are congruent to 2 out of the 3 triangles of another triangle, then the third angles must be congruent. So let me just kind of draw you a picture. Let's say if I told you that this angle was 80 degrees, this one's 80, and let's say, so those are congruent. And then I tell you that this one is 40, and then this one is 40. That means that whenever we go to find that third angle, you do 180 minus 80 is 100, minus 40. That would only give you 60 degrees left for each of these angles. So that third angle ends up being forced to be congruent. So even if you only start with 2, AA, well, let me go back. Let me color code that correctly. We're going Christmas colors here. Even if we only start with 2, angle similarity, we end up getting to add that third angle must be congruent. Okay, so they shorten that and they just call it the angle similarity shortcut. So if you don't know anything about the side lengths previously, like before today, one of our most recent lessons, you had to first ask yourself, were they the same shape? Second, you checked all of the angles and made sure they were all the same. And then you had to check all 3 of the side lengths of the triangle and make sure that they were proportional. Now you get to stop at that second step. So these 2 triangles, these are both triangles, and then they have an angle marked that is congruent to this angle because those are both 75. And then both of these angles are 31. So I would say that these triangles are similar to each other. They're similar by angle similarity. So I'm going to practice writing every now and then. I'm going to throw in a triangle similarity statement just so that y'all have practice doing that. So who would you say is similar to triangle CAB? If you named the one on the left CAB, you have to name it in the same order. So FDE, that's red and then green and then a blank. So red and then green and then a blank. Those are similar, and if it said like by what reason, you'd say that's the angle similarity shortcut. So even though we know nothing about their side lengths, we know that for sure that they're going to be proportional, even though I don't know that they're numbers, because if these triangles are similar, then we have a similarity ratio between the sides. Okay, so this one doesn't have any numbers at all. These 2 triangles don't have any numbers, but I do have, so far at least, I do have one set of angles that are marked as congruent to each other. So you might think that that's not enough information, but because these triangles are overlapping, I can add vertical angles right here. We know that the vertical angles theorem tells us that vertical angles are congruent to each other. And so now I have 2 sets of angles marked as congruent, a set of blue and a set of pink. And so I can say that these triangles are similar to each other by angle similarity. So let's say that you went WXV. You'd say that that triangle WXV would be similar to WXV goes from no marks to 2 marks to 1 mark. So no marks would be Z, to 2 marks would be X, to 1 mark would be Y. So those are similar to each other by the angle similarity shortcut. Okay, on this one I see overlapping triangles, and so I always want to pause because this is what my students tend to struggle with the most. We have this small blue triangle, and then we have this bigger pink triangle, and they're overlapping. And we notice that they're overlapping at an angle. Angle L is included in both of these triangles, so we can add that. Those are overlapping there. But we also notice that these little marks right here, these aren't on here for funsies, okay? These little triangles say that these lines are parallel. So if those lines are parallel, so I'm going to mark those in green. If those lines are parallel, we know that corresponding angles are going to be congruent. So I can add a set of angles here. Those are going to be congruent. I could also, if I wanted to, add another set of angles over here with this transversal. These would also be congruent to each other. So you end up having all three angles congruent, but you really get to stop at 2. So let's say I named one of them triangle PQL. I would say that that is similar to triangle PQL, would be 3, then 2, then 1. So 3, then 2, then 1 would be NML. And that is by angle-angle similarity. So here's 3 examples where you can say that the triangles are similar by angle-angle similarity. So what is side, side, side? How is that different? Well, instead of having to check the angles, it's also sufficient to just check the sides. If the sides are all going to be proportional to each other, that means the angles end up matching, and then you're able to prove the shapes are similar to each other. And so I've got 3 sets of sides here. I'm going to highlight them. 3 corresponds to 6, 4 corresponds to 8, and last but not least, I'm going to go a different color, 5 corresponds to 10. And so when I'm checking those, I want to make sure that those ratios all reduce to the same amount. So like, let's say I went 5 to 10. 5 over 10 reduces to 1/2. We have 3 over 6. That also reduces to 1/2. If you notice, you can kind of look at it. All of these are just doubling. So that first shape is half the size of that second shape. That second shape is double the first shape. So since all of these reduce to 1/2, by side, side, side similarity, side, side, side similarity says that these triangles are similar to each other because those are proportional. The sides are proportional to each other. And we don't know anything about the angles. I don't know if those are right triangles or not. I don't know what the angles are, but I don't need to know anything about them. This shortcut allows me to prove these triangles are similar without having information about the angles. They end up having to match. Okay, again, we have this overlapping thing going on, so I like to slow down and highlight just because I simply know that this is where my students struggle. So we have this little pink triangle, and then we have this big blue triangle. So make sure when you're comparing sides, you're comparing full blue amounts and full pink amounts. So the first part is easy. When I'm comparing the 30, that's the full pink amount to the full blue amount. So that's going to be 30 over 42. What does 30 over 42 reduce to? So you're just going to simplify that fraction. Remember, we always want ratios to be in simplest form. That is 5/7. So as long as the other 2 pieces also reduce to 5/7, then these 2 triangles are similar to each other. So what about when I pick the 20? That's the entire left-hand side of the pink triangle. So what is the entire left-hand side of the blue triangle? It's not 8, it's 20 and 8. So 20 plus 8 gives me 28. So make sure you're comparing corresponding pieces. So the 20 compares to the 28. So 20 over 28 does, in fact, reduce to 5/7. So far, so good. Let's do the very last piece, 15. That is the entire right-hand side of the pink triangle. What is the entire right-hand side of the blue triangle? That'd be 15 and x, or 15 plus x, which would be 21. So 15 over 21 also reduces to 5/7. So because of all 3 of these reduced to 5/7, these triangles would be similar by side, side, side similarity. So let's say you named the first one VXW. You can name the first one however you want. That would be similar to VXW, would be similar to UYW. VXW went here, and then here, and then here. So UYW. All right, when we get to this one, again, we have 3 sides listed. Now, I did want to mention we could add vertical angles to this picture if we wanted to, which might actually be a little bit less work because once you add those vertical angles, you could do side angle side, and so you're only having to check 2 fractions. But we're going to go with what's here, okay, just for purposes of simplicity. And so when I am looking at the 15 and trying to decide who it corresponds to, 15 is bigger than the 5. Like when I'm looking at those 2 pieces, 15 is bigger than this 5. So I want to put that with the bigger piece between 54 and 18. So these 2 pink ones are going to correspond. 5, the smaller piece, corresponds to the smaller piece. And then again, we've got the 12 corresponding to the 43.2. So I'm just going to check all of these fractions. 15 over 54. I believe, let me double check, but I believe that that simplifies. I think it's, yes, it's 5 over 18. Okay, so let's keep going. Now let's do the blues. 5 over 18, those are the blues. That's already fully simplified. That's fully simplified. You could type in your calculator just to double check. And then 12 over 43.2. Now this is interesting. When you type in a decimal, remember that ratios have whole numbers in them. So when you try to type in 12 with the fraction button, 43.2, it's going to give you an error message in your calculator. So what you can do in this situation is just change to a decimal or change to a division symbol whenever you have that decimal. So 12 divided by 43.2 gives me 0.27. It looks like repeating. Make sure that when you type in 5 divided by 18, you get that same thing. That gives me 0.27 repeating. And so since all three of these are the same, these shapes are similar. So I would say, let's just say I called the first one triangle ARP. That would be similar to triangle ARP would be TRY, triangle tri. You could put two things. You could either say by side, side, side similarity, or if you threw vertical angles on here, pink and then the vertical angle in the blue could be by side, angle, side similarity. So either of those shortcuts would work. Both accomplishing the same goal, which is to prove that those two shapes are similar to each other. All right, and then last but not least, we've got side, angle, side. Now notice, remember SAS, the sassy one, is where the angle is included in between those two sides. Okay? So it makes a sandwich, in other words. So how do I know who goes with the 8? So let's color code a little bit better than that. Hold on. Let's check the angles first, because if the angles do not match in between, then you could not use this shortcut. So those angles are marked as congruent, so that's good news so far. Who corresponds to 8? Well, between 8 and 20 on the triangle on the left, 8 is smaller, so it should correspond to the smaller piece, which is going to be 6. So we got to see, does that side simplify to the same thing as the other set? So let's check. So that means that 20 is going to correspond with the 15, so that makes my sandwich. So now we just need to check those fractions. 8 over 6 reduces to 4/3, and then 20 over 15 also reduces to 4/3. So those two sides were in the same ratio, and so by side, angle, side similarity, these triangles are going to be similar to each other. So I could say triangle, let's say I did JKL that goes across blue and then across pink is going to be MNP, across blue and then across pink. All right, let's do this one. We've got our vertical angles again. So I get to add those in the middle. Those are congruent to each other. And then how do I tell who corresponds with the 24? 24 is smaller than 48 in the triangle at the top. So we need to put that with the smaller piece, which is going to be 6. So 24 over 6 reduces to 4 over 1. Let's see if that is the same ratio as 48 to 12. 48 over 12 also reduces to 4 over 1. And so these are similar by SAS similarity. These triangles are similar. So I could say triangle FEG, that goes across blue and then across red, is similar to RES, triangle res. Okay. Again, I slow down once I get to one of these because I know that this is where people struggle. Here is my small pink triangle. Here is my big blue. These are overlapping. These are laying on top of each other. And so when I compare pieces, this is side, angle, side, I immediately can tell that I have an angle that overlaps at the top. Angle W is in both of these triangles. So as far as SAS goes, I've got the angle at the top. And now I need to check my corresponding pieces. So what is the left-hand side of the pink? That's going to be 15 over, so 15 over the whole thing of the blue. 30 plus 15 is 45. So 15 over 45 reduces to, that is going to be 1/3. Now let's check the other piece. 14 is the right-hand side of the pink. That corresponds to the whole right-hand side of the blue, so I add those together, and that's 42. That also reduces to 1/3. So that was those added together. Okay, if they're the same, I can use side, angle, side similarity to say that these are similar. So I might say something like triangle SWZ is similar to triangle QWR, that one laying on top of it, by SAS similarity, without knowing anything about those third sides or those other angles. Okay, so this last part is just going to tell us we want to pick the shortcut if the triangles are similar. If not, you're going to say not similar. Okay, so this one looks like SAS similarity. That's what we think, but we're going to test that theory. So here's my vertical angles. Those are, in fact, similar to each other. Those are congruent to each other, I should say. So the angles are congruent. Now let's check the pieces, the corresponding pieces. 12 is smaller, so it corresponds to 16. 12 over 16 reduces to 3/4. Okay, so let's do the other set. 15 over 20. 15 over 20 also reduces to 3/4. So because those are the same, this is in fact side, angle, side similarity. So TXU would be similar to, so that's across blue, across yellow would be VXW. So that is a shortcut that works for SAS. And it looks like that exact same problem is here, except for it has different numbers. So let's see why I would do that. Here's vertical angles. We're thinking it's SAS similarity, question mark, we're not sure. Vertical angles are congruent. 87 is the smaller piece. So since 87 is smaller, that should go with the 68. 87 over 68, I do not believe that that reduces at all. Okay, let's check the other set, 95 over 72. 95 over 72 does not reduce at all either. Since those are not the same, then we do not have a shortcut, and these shapes are not similar. These are not going to be similar, so you're not going to have a similarity statement. Okay, so sometimes you check the math, and the angle between is congruent, but the sides fail to be the same. And when I say the same, I mean the same ratio. They're in the same ratio. They're proportional to each other. So again, I have another one of these overlapping. So slow down. Little blue, big pink. And so this looks like SAS, but let's check. SAS. There's a right angle in between. So that A is checked off. Let's check the sides. This is going to be 6, small piece, of the left of the blue triangle, over the entire left of the pink triangle, which is going to be 6 plus 6, which is 12. So 6 over 12 equals 1/2. Is that the same ratio as 8 over the whole thing? 8 plus 8 is 16. Yes, because 8 over 16 is also 1/2. So since those are both 1/2, this is side angle side similarity. What does that mean? That triangle AEC is going to be similar to triangle AEC would be AWL. AWL. All right. Last but not least, let's do these three and then we'll stop. We're going to finish this and do a fun activity with our groups tomorrow to practice this. So I'm anticipating, if I had to guess, which of the 3 shortcuts would you guess? SSS similarity, SAS, or angle. What's marked in this picture? Well, we're thinking that it's side similarity, but let's test it. Test our theory. 22 is the smallest piece. It corresponds to the smallest piece, which is 16. 22 over 16. What is 22 over 16 reduced to? You don't want the mixed number. You want the improper fraction. That's 11/8. So you just divide both of those by 2. Okay? So as long as the other 2 fractions reduce to 11/8, then we're golden. Here's 28. Here's 20, both the medium-sized amounts. 28 over 20. 28 over 20, when I reduce that and put it in an improper fraction, is not going to, I do not believe, is not going to reduce to the same thing. So 28 over 20 reduces to 7/5. Well, 11/8 is different than 7/5. So this is going to not be similar, and so you're not going to have a shortcut. So I don't even have to check that third piece, the 25 and the 35. I don't even have to check that because it's already failed. Okay? Again, they do not, on this next problem, they do touch, they intersect, and I get to add some vertical angles there if I choose to. And then they do not put these triangles on here for fun. That means that these lines are parallel. So I get to add 2 sets of alternate interior angles using those transversals. 1, 2, 3. And so by angle similarity, without knowing anything about those side lengths, we know that these are going to be similar to each other. And I did need to fix this. This is supposed to be PMB. PMB. So what is that going to be similar to? PMB is going to be similar to P to M to B. So red, blue, yellow. Red, blue, yellow would be ACB. Okay. And then last but not least, I needed to change this to an E if I remember right, GFE. Last but not least, let's look at this set. This is looking like side, but let's check it. Side, similarity, question mark. This is an isosceles triangle. Both of these are 6 and 6, 8 and 8. So you can write it twice if you want. I'm not going to because I know that 6 over 8 reduces to 3/4. And I'm rewriting it wouldn't change anything. That's still 3/4. And then I'm going to check the 9 over 12. Does 9 over 12 reduce to 3/4? It does. So you'd have all 3 of these reduced to 3/4. And so by side similarity, these are similar. So GFE would be similar to CBA. You start at the vertex angle like they did up here. Or you could also say CAB. Because these base angles are going to be congruent to these base angles, it doesn't matter if you say CAB or CBA. Okay, we will do the rest of this as practice for tomorrow. And I hope y'all have a wonderful evening. No homework tonight.